All right, let's cover now the second part of the history of how computers encode written language. And I can start out by saying that if you think about the question of can computers process, handle, store all ways of processing or speaking, or in this case, writing all languages, that if we think of all the possible ways that computers can process, store, handle spoken or written language, Unicode and encoding the written language is as close as we've come to being able to say, yes, we can do this. We can handle all ways of writing all languages with computers. So if you go back and think about the first part with ASCII, the American standard way or the standard way of encoding American English characters, which became very common across the internet, was used by a lot, and other languages often extended from ASCII. It still led to this Wild West era of character encodings, where there were a lot of systems that existed and there was overlap between the systems, not they weren't coordinating between the systems, and the systems would work differently if you had different programs or different computers with different default encoding set up, or you just wouldn't know what encoding was coming in, so you wouldn't know how to encode it. Um, it was it was a mess, and for people who were reading or writing more than one, not just more than one language, but more than one writing system, could be within a single language, had to deal with this problem on a daily basis. And so ASCII was established in 1963, um, and its last update was 1986. And already by that time, even as the internet was just appearing and people were exchanging across computers, even without the internet, it was already clear that this wasn't going to work. This Wild West approach to everybody doing their own encoding systems without really paying attention to the other ones wasn't really going to work. And so in 1988, a new solution was proposed, and this is Unicode. And Unicode is unlike ASCII, which is like a table, and there's all the other encoding systems that it could be represented as tables or charts that number to character. Unicode encompasses all that, but it's kind of maybe better to think of Unicode as more of a movement or even an organization, if you will, that encompasses a bunch of different encoding, but in a way that works for all. So you could understand what it was trying to do by looking at its motto. The Unicode motto is that Unicode provides or will provide a unique number for every character, no matter what the platform, no matter what the program, no matter what the language. That's Unicode's motto, and that's its goal. So how did it go about doing this? So Unicode was first proposed in 1988. So the last update to ASCII was in 1986. 2 years later, they said this isn't gonna work. We need a better way of doing this. And the goal was to replace all encoding systems. I would actually say it probably would be more accurate to say to encompass and unify all the different encoding system schemes under one movement or organization or one big grand scheme called Unicode. And the first version was published in 1991, so 3 years later. A key thing to know about Unicode is that it's 100% backwards compatible with ASCII. So it's not, there's ASCII and Unicode, and they're two different things. Unicode encompasses ASCII, and ASCII was the one that was fully adopted into Unicode. The other systems, if they had no overlap with ASCII, so they had their own unique numbers, as much as possible, they were also encompassed in Unicode. But for a lot of them, where they were using same numbers for different characters or different characters for the same number, they had to be adjusted, and they were adjusted to keep ASCII the same, and the others were adjusted. So that's a key thing. So if you're only using American English characters to type, your computer can just be set up for ASCII, and it's not that it's ASCII but not Unicode. It's ASCII is a smaller, only requires 1 byte. Unicode is much bigger, and so if you only ever need English, you're just maybe going to download and install that part of Unicode, which is known as ASCII. Okay, So all this encompassing and adjustment was is coordinated, still coordinated by the Unicode Consortium, which is a nonprofit organization. And then since 2002, there's been another nonprofit related to this movement and work called the Script Encoding Initiative, or SEI. And it has funded through grants and other nonprofit activities the encoding of new scripts to reach that motto of representing all characters in all languages. And so today, Unicode, the latest version, was released in September of last year, September 2024. And that newest version, since the previous version, which was released 2 years earlier, had added over 5,000 new characters and 7 new scripts. So those scripts included those 5,000 new characters, perhaps a few more. I really don't know. That list of new scripts, I've honestly never heard of any of them. So if you want to find out about them, I encourage you to go to the website omniglot.com and see if you can find them and see what you can learn about these scripts. In addition to those additional scripts with the characters in them, the newest version included 8 new emojis. So we're also, with Unicode, not only representing characters, but they're also giving unique numbers to emojis. They must be really confident that they're going to have enough unique numbers to represent all characters and all languages and still have room for emojis, which, uh, spoiler alert, they do. The total, what we have right now in Unicode 16, with those 5,000 and new characters and 7 new scripts included, is 168 scripts or writing systems that are represented. This includes nearly all modern logographic systems, alphabets, abogidas, syllabaries, abjads, as well as some classic ancient ones and some very lesser known ancient ones. With 168 scripts represented, plus all the punctuation and other instructions that are needed for text processing in computers, 155,063 characters have unique numbers. So that is more than 100 times more than what is represented in ASCII, which has 128 possible unique characters and numbers for each of those characters. So it's quite significant growth. It's well on its way, presumably. I think there's something like estimated nearly 300 scripts. So there's still a lot more to go as far as scripts to incorporate into Unicode. So can Unicode represent all ways of writing all languages? Will it be able to do that without running out of room? Well, there's a simple answer to that, which is Unicode is designed to take or to have up to in its storage 32 bits or 4 bytes. So 8 bits per byte, that's 4 bytes. So that's a simple answer. And isn't you're taking this course, you know how binary works, you can know how to calculate that, and you could give the total number of unique characters that can be represented in 4 bytes. But you can also get to it just by estimating, right? And knowing how the system works. So ASCII uses 1 byte, including the extra 8th byte for information. 1 byte, this is 3 additional bytes that Unicode has available to it. But this is not quadrupling. It's not just quadrupling the number from 1 byte, right, which is 256, because with the numbering system, each column that you add grows exponentially. So it's not just 4 times 256 that's available in 1 byte. The total number that Unicode has as available unique numbers for individual characters is 2 to the 32nd, including that 0, gives you over 4 billion unique pieces of information represented with unique numbers. That is a lot. So it seems like, yes, we not only have enough room for all the scripts in the world, but we're going to have a little additional room for some other maybe combination of characters that are frequently used, emojis, punctuation, even new punctuation, and who knows what else. So yes, Unicode seems to very likely unless the number of writing systems just explodes in the future, it seems very likely to be able to represent all ways of writing all languages. So it does seem, of all the ways that one could represent, process, or handle all ways of speaking and writing all languages, when it comes to representing the written language, computers are pretty close to solving it. They can handle anything when it comes to just writing, which is about the only thing as you continue in this course you'll see that computers can handle with language more or less completely. So that's nice. We got a solution to this. Let's look a little bit at Unicode. Let's explore this a little bit. So Unicode is a great big system, right? With over 150,000 unique numbers. That's a lot to flip through. If you want to go to the Unicode website, you can look and see the table. You know, ASCII table we could fit on one slide. You can't do that with 150,000 characters and still make sense of it. But it's nicely organized. So you can go to a certain range in those numbers. So the Cyrillic alphabet, for example, if you look there, in the little box that's highlighted in blue down there on the side, it says range, and then it starts with 04, and then 00 through 04FF. This is represented in hexadecimal. FF is the highest digit available. It represents 15 in the hexadecimal system. Hexadecimal is a nice compact way of representing bytes. Not surprising, right? You have 8 bits in a byte. A hexadecimal is 16, so there's, 8 times 2. There's a relationship there. Won't go into more detail right now. So it's a much more compact way and more easily predictable way of representing values of bytes than the decimal system. So that's what you're seeing there. So across the top, you're seeing this layout where across the top you have the hexadecimal numbers 0 through F. And I don't have it here, but essentially you can imagine from the top to bottom. I don't have full 16 rows, but there are 16 rows that also have 0 through F. So you can then follow from the top and from the side to a particular character that you want, and you can see what the last 2 digits are in hexadecimal. So it's kind of nice. So there's all sorts of planning that goes into it. It's simple but elegant. The nice thing, for example, with a Cyrillic is if you want to type a Cyrillic and you only ever plan to use a Cyrillic keyboard, then you don't have to download and install the whole Unicode, all, 4 billion plus possible numbers and have your computer deal with that. You could just download the range of that starts with 04, and pretty much that's the whole range there from 00 to FF in the last 2 numbers. And then you don't have to worry about the first 2, 04. Your computer only has to worry about the 00 through the FF, the last 2 numbers in that range of 4 numbers, right? So that makes sense. Like I'm just going to go to that. I only want the Cyrillic. Okay, everything's going to start with 04. I'm only going to worry about the unique numbers that come after 04 from 00 to FF. So then my computer only has to deal with those numbers. So it reduces the amount of storage needed. So there's all sorts of different unique, elegant, but simple systems that are built into Unicode. It's very nice. That just gives you a little overview. So if you want to type in Cyrillic, if you speak Russian, and if you know Russian, you'll see there very quickly, there's more than just the Russian characters. There is characters used for Ukrainian and minority languages that are built off of the Cyrillic alphabet. There's also the Old Slavonic, the older alphabet that was used for Slavic languages before the modern Cyrillic alphabet. It's all represented there in that range of the Unicode numbers. So there's Cyrillic as an example. Here's another example. That was an alphabet. Here's the syllabics. These are from a syllabary that is used by many of the Canadian First Languages across central Canada. So it's called Unified Canadian Aboriginal Syllabics Extended. It covers multiple languages like Cree and so on. And those are syllabic symbols. And you have the range, so you could people who speak those languages can type in those languages and represent and display all the characters of their language. And you even have, as another example, Egyptian hieroglyphs. So if you wanted to type your final paper in Egyptian hieroglyphics, you could do that. I don't recommend it because I can't read it. And as far as I know, none of my teaching assistants can read Egyptian hieroglyphics. So unless you can also point us to a very high quality machine translation system between Egyptian hieroglyphics and the English words, we might have to give you, unfortunately, a low grade on your final essay if you were to type it in Egyptian hieroglyphs. However, I wouldn't give you an F because if you can figure out how to set up and type Egyptian hieroglyphics on your computer, that would be very much in the spirit of this class. So, hey, have at it, but at your own risk. So that's Unicode.